Hello, this is John from caveofprogramming.com. In this tutorial we're going to take a look at move constructors in C++11. So I've got this test class here from the last tutorial. I'm just going to clean it up a bit and get rid of some of these, well, all of these couts in here because they're kind of confusing what we see now. We don't need them anymore. And let's get rid of these check functions. We don't need those. And get rid of everything apart from this bit where we're adding a vector. We're adding the test class to a vector. So now I've just got my test class with its various constructors and destructors and whatnot. And I've got this vector where we're adding a temporary sort of test object. So the move constructor looks a lot like the copy constructor, except it uses R-value references. So let's create a new constructor here, and the move constructor has to take a mutable R-value reference for a reason that we'll see in a minute. It can't be const because it has to change other. And one thing that I'm going to do before I forget is just go to the top here and let's initialize this pointer here with null pointer, because really that's good practice and I should really have done it earlier. We want to make sure that it's null if we don't allocate memory, because that will help us get rid of any bugs. So in the move constructor, the idea is we're going to get some sort of temporary object here, something that's not named. It's going to be an R value, and we want to just steal the resources from it, which is easily done. All we have to do is say, well, whatever resources that are allocated using new in the other object here, we have to steal those. So let's say here, because we've only got underscore p buffer, it's the only resource that we need to steal for this class. We're just going to set it equal to other dot underscore p buffer. So other has done the hard work of allocating this buffer. Now we're just going to steal it. This code as it stands now has a problem with it. Actually, one thing I should also mention is that some people like to check that other in situations like this, and with the assignment operator as well, they like to check that it's not the same as this, because it would be stupid to try to copy the object to itself. But personally, I think in most situations, if you try to do that, then you kind of deserve all the problems you get, because obviously you shouldn't do that. So I usually don't put that in, but you can put in a check to make sure other is not equal to this if you like. But even so, there is a problem with this which you might spot. So if you want to pause the video now and puzzle over that, then please go ahead. And the problem is that, of course, the destructor of other will deallocate that buffer, and we've stolen the buffer, so we don't want that to happen. So in this situation here, the copy of test that the vector stores by copying this one would then the actual original would try to deallocate the memory that vector had stolen for its internal storage. So to deal with that, all we have to do is set other dot underscore p buffer. I can't get used to this starting with an underscore, equals null ptr. Because although I thought I remembered way back more than 10 years ago that deleting a null pointer caused terrible problems, but either I was imagining that or something's changed, or maybe I was trying to delete pointers that were not null but actually pointed somewhere. In any case, it is safe now to call delete on a null pointer. Let's just put some text in here so we can see that running. So let's say move constructor. So we've stolen any resources that the R value actually owns, and then we're setting them to null in the R value object so that it can't deallocate them itself. And if we run this now, we see that the move constructor is running, and where that's coming from is indeed this here, because vector is copying this test object, but now it's doing it using a move constructor. And because we don't have to allocate any more memory in the move constructor, like in the copy constructor, we have to allocate memory, but in the move constructor we don't. We're just changing a couple of variables, so it's very, very efficient. Okay, so that's it for this tutorial. We'll take a look at the move assignment operator in the next tutorial. Until next time, happy coding.